Hello everyone, this is Vasant, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve some questions on fluid mechanics from quiz 1 question paper of IIT Bombay. This is the question paper. There are 11 questions in this quiz. So we are going to solve some questions of this quiz in this video. So let's start. So this is the first question over here. The first question is, a fluid is one which can be defined as a substance that has small shear stress in all directions, has same shear stress at all points, is always incompressible, can deform indefinitely under the action of the smallest shear force. Let us understand each and every options of this question. So has small shear stress in all directions. If you see small shear stress, see the quantity how, whether it is small, whether it is large, it depends on the quantity of shear stress applied on the fluid, right? So if you apply small quantity of shear stress, then there will be small shear stress, right? So if there is if you apply large quantity of shear stress on the fluid, there will be large shear stress at some points, and it may decrease on going different directions, but it may have large shear stress, right? So he given that has small shear stress in all directions. That is wrong, right? So this one is wrong, because it depends how much shear force you applied. Next, has same shear stress at all points. Is wrong. So if you study fluid mechanics, you already know for a Newtonian fluid, tau is equals to dou u by dou y, right? U is velocity variation. So if velocity variation is linear, then dou u by dou y is equals to 1. Dou u by dou y is equals to some constant, not 1. So then tau will be constant. Then it will be equal at all points. But if u is any other, not any other function, suppose if you take a quadratic y square, then dou u by dou y will be linear in y, then shear stress will be linear in y. So we can't say always that same shear stress at all points. It depends on the load, it depends on the conditions. In only one case, one or two cases, we may get that same shear stress at all points. That is the case of linear in y, means if velocity variation is linear in y, then we are getting tau is constant at all points. But it is not the case with all velocity variations. So this option is also ruled out, right? Because it depends on velocity variation. So next is always incompressible. This is also wrong. See, if your body is incompressible, this is for P. If incompressible, then we have K is equals to infinity, means very large. Okay. So, but if you observe many fluids has large K value, so that means they are compressible, right? So this is wrong. May be compressible, may or may not be. Okay. So can deform indefinitely under the action of the smallest shear force. The basic definition of fluid is that on application of the shear force, it will infinitesimal. If you apply a small amount of that we call as infinitesimal quantity of shear. On application of infinitesimal quantity of shear, this substance, i.e. fluid, will deform indefinitely. This is the basic definition of fluid. So this answer D, option D is correct. Okay, I think you understand. So let us move to the second question. If the fluid and flow characteristics over the flow domain do not change with time and location, then it is called. Before solving this question, let us discuss few concepts. So actually in fluid mechanics, there are two approaches. One is Lagrangian approach. Another is Eulerian approach. Okay. So Lagrangian approach is the approach which we generally use in rigid mechanics, where the whole body moves with same acceleration, same velocity kind of thing. But in case of fluid mechanics, so what is Lagrangian approach? In Lagrangian approach, we generally take a particle and we see the whole, how it is moving. The path of the particle will be traced. Means if you take a particular particle and each and every particle of a fluid will be traced, and its kinematics will be drawn from the path it followed. Okay. So in fluid mechanics, each particle followed different paths. So we are not sure that all particles will follow the same path. They may follow the same path, they may follow different path. So we need to find out each and every particle's path. So that is very tedious task. And in this Lagrangian approach, the integral equations which we get from this approach are difficult in most cases. So generally we use Eulerian approach in fluid mechanics. So what Euler did is that he don't care about the particles which are moving in the fluid. Suppose if you take one flow field, suppose fluid is flowing in this region, so this will be flow field. Okay, so he will take one particular position. Suppose this is some x comma y comma z, and in this position, for this position he will analyze the time variation of the quantities. Means suppose how velocity is varying, how acceleration at this point is varying. So he will say that for this point at any instant of time the velocity is varying like this. For this point at any instant of time the acceleration is varying like this. So at an instant of time, whenever a certain particle will come to that position, so at that instant of time the velocity of this position will be equal to the velocity of that particle which came to this point at that point of time. Do you understand? Because see, fluid particles are moving, so at different instant of times different particles will pass through this point. So at a particular instant of time, if a particular particle is passing through that point, then the velocity of that particle, the acceleration of that particle will be is equals to the velocity and acceleration of this position calculated by the Eulerian. Do you understand? So this approach seems easy, right? So this is location comma time. So how the velocity and accelerations are varying with the location and varying with the time. That is analyzed by the Eulerian, which is a easier method compared to the Lagrangian, right? So generally we use this method. So the velocity, comma acceleration are functions of position, comma time. Okay. So in this case, if a body is such that it is not changing with position, means suppose if this is the flow field, at a given instant of time, at every position the velocity and accelerations are same, the flow characteristics are same, then it is said to be a uniform flow. So uniform throughout the body, uniform throughout the flow field at a particular instant of time. So uniform flow case mein velocity comma acceleration, any flow characteristics will be function of time only, right? And another thing is steady flow. So in case of steady flow, they are steady with positions, means they are steady in time, means with time they don't change. Means once the flow started, they will have some velocity and acceleration at different points of positions. At every time, at an instant of time, the velocity and acceleration remains the constant. So here the velocity comma acceleration are functions of position only. They are independent of the time. So if you see the question, they are not changing with time and location, then it is said to be, if it is not changing with time, then it is said to be steady, right? If it is not changing with location, then it is said to be uniform. So this B is the answer. Okay. Let us move to the next question. For a fluid mass at rest, the following forces act. So a fluid is at rest. So which of the following forces will act on the fluid? So if you consider a small differential element of the fluid in cubical shape, if fluid is at rest, then it should be at rest, right? That means it should be in equilibrium. So the net forces acting on the body should be zero. We already said that if you apply infinite decimal value of shear force, then the fluid will deform infinitely, right? Means it will have movement, right? So if there is shear force on the body, if shear force, because of shear force, movement, deformation will happen, right? So for a fluid at rest, the shear stress should be zero. So no shear stress. For fluid at rest. Okay. Now let us come to the body force. What is body force? See, there are generally two types of forces. One is body force, another are surface forces. See, surface forces are those forces which act at the surfaces of contact. See, if you suppose see normal force acts on the surface when it comes to contact with the ground. It will create a normal force on the surface where there is contact, right? And suppose shear force also when two bodies will contact and shear each other, then shear force will come. So these two forces, shear force, shear force, normal force, normal forces are surface forces. But what about body force? Body force will act throughout the body. Body force will act throughout the body. So it is gravitational force, right? So gravitational force will act throughout the body. Wherever there is mass present, there is gravitational force if the value of G is non-zero. So this will act throughout the body. So this is a body force. Surface force are shear normal. Body force are gravitational force, electromagnetic force, those things. So in fluid mechanics, we generally deal with gravitational forces. We won't deal with electromagnetic forces, right? So these are surface forces. So whatever part of differential element you may take that has some mass, so body force will present, right? Body force mg. So body force should present. So in this option also body force is there, this also body force is there, this also body force is there. But shear force should not be present. So this is wrong, this is wrong. Now let us come to normal force. See, when this body comes in contact with another fluid और ऊपर में एक और फ्लूइड कांटेक्ट में होगा, इस डायरेक्शन में एक और फ्लूइड कांटेक्ट में होगा, इस डायरेक्शन में एक और फ्लूइड कांटेक्ट में होगा. So because of the contact, normal forces will develop, but those normal forces also, whether they are compressive or tensile. See, if they are tensile, then it will deform, right, again. But the fluid is at rest. If the fluid is at rest, they are not moving at all. So it will deform infinitely. So the normal force which is there, the normal force, then one more thing, the normal force should be compressive. Can't be tensile. Next, body force. Body force is gravitational force acting over there, right? So for this question, the answer will be D, body force and normal force. With this, we end today's lecture. In next lecture, we solve some more problems of this quiz. Thank you.